All right, 15.3, geometric sequences. So geometric is similar to arithmetic, but it has a common ratio. Okay, so we're going to do the same basic stuff we did yesterday, but with multiplying instead of adding and subtracting. Woohoo! All right, so you look here, and the question is, which of the following is an arithmetic sequence? Okay, and an arithmetic sequence is one with a common difference. So if you can go up by the same number every time, it's a arithmetic. So this one is arithmetic because you go up by 3. The common difference is 3. And this one is arithmetic because you go down by 5. You subtract 5 every time. That's your D. These two are not, because this one you go up by 5, and then here to here is 10, and then here to here is 20. So this particular one you're actually multiplying by, you're multiplying by 2. Okay, and this one looks like you could be multiplying by -2. So these are what you'd call geometric because they go up by a multiple. Okay, so again, whenever you have a geometric sequence, you're multiplying to get to the next term. Okay, multiplying by a fixed amount, that is called a common ratio, or we call that R. So to find that, we divide one term by the term before it. Okay, so to find the common ratio here, I'm just going to zoom in a little. So to find the common ratio for this one, you just take one term. It doesn't matter which one. Generally, you take the easiest one and divide it by the one before. So 10 is this term. The one before is 5. So the common ratio is 2. Check it out to make sure. 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. That looks about right. This one here, now looking at this one, I would take -3 and divide it by 6. I don't know if I would take the 3/2 and divide it by -3. You know, fractions, negatives, all that stuff. So I would do one term divided by the one before it. This turns out to be -1/2. So that's a common ratio. How you find it is you divide one term by the term before. Okay, so we may want to find a specific term of the sequence, so we really just need to find the common ratio, and then you just multiply. Sometimes that is the easiest way to just do these. Figure out what you multiply by, and then just do it. So I did the multiplying earlier, so hopefully I did it right earlier. So let's use blue. So what's the common ratio? R is 6 divided by 2, which is 3. So this is the first term, second, third, fourth. So the fifth, I'll just do this, would be 54 times 3. Again, sorry, that's my computer programming showing up. So that's 162. And then a 6 is 486. You just multiplied that by 3. And then a 7 is 1458. All right. So same deal with this one. What is the common ratio? So the common ratio is -1/3 divided by 1, which is just -1/3. So we simply multiply each one of these by -1/3. So an alternative way to do this is the first, second, third, fourth, fifth, sixth, 7th, 8th. So we want the 8th term, so we just simply multiply each one of these by -1/3. So what that does is it makes it so every other one is going to be negative. So this particular one, it's a negative times a negative, so it's going to be a positive 1/81. And then this one is going to be a positive times a negative, so that's going to be -1/243. And then the pattern continues. So this is negative. Negative times a negative is a positive. And then whatever. This is going to be negative 2187, I hope. Okay? Alrighty. So find the nth term. So just like the other one, geometric, there is a formula. Here is the formula. Notice it just takes everything up a notch. Yesterday's we were adding, this one we're multiplying, and A1 times the common ratio. And yesterday we multiplied the common difference times n minus 1. This time we're raising it to a power. So it just takes it up a notch. You're given this formula, I believe. You don't have to memorize this one, but you do have to know how to use it. Okay, so if you want to use the formula to find the 9th term of this sequence here, we actually have to find it. Find the 9th term. So we do the same basic thing that we did yesterday. I'm going to try to keep that formula up there. Okay, instead of the common difference, we want to find the common ratio. So that's 6 over 4. And 6 over 4 is 3 over 2. I just like it in simplest form. It doesn't really matter if you do it or if you don't. And then you plug everything you know in. So we know a sub 1 is 4. So again, I'm looking up here at all these pieces. So I know what the r is now. I know what a1 is. What's n? Well, n is my 9th term. So n is 9. And I plug those things in. So a sub 9, which is what I don't know, is equal to the first term times the common ratio, which is 3 over 2, to the n minus 1 power. So that's 9 minus 1, or 8. Okay, there's the n. N minus 1 goes up here. I don't like writing n minus 1 there, so I'm just not. Okay, you just plug that in your calculator, and a sub 9 is 102.52. Okay, again, I'm sure you'll let me know tomorrow if I mess that up. So, sometimes you're going to be given a term, like here's the first term, here's the 5th term, can you determine the common ratio? So again, it's very similar to yesterday. We're just going to be using the formula, just a little bit added extra stuff when you are, when you're using exponents instead of just plain old multiplying. So we just plug it in. So T1 is this one, T5 is this, so I'm going to plug it in like this. Generally, we want this one to be the farther along term. We keep T1 the same. Okay, times the common ratio, which I don't know, to the n minus 1 power, and so it's this one minus this one. So T5 I know, that's 3 over 8. T1 I know, that's 6. R I don't, but 5 minus 1 is 4. And we just solve. So I know sometimes this looks kind of disconcerting, but just remember, always do that inverse operation. So I divide by 6. 3/8 divided by 6 is 1 over 16. These divide away, and we're left with r to the 4th. You can do the 4th root, or remember you flip the exponent. So the common ratio is 1/2. Okay, next one, try this one on your own. And then fast forward me, because I'm going to step through it, but you should just pause it, try it on your own, and then fast forward to the answer. That's a good idea. Okay, so I'm going to do t to the 4th equals t to the 1st, r, 4 minus 1. T to the 4th is negative 81 over 32. T to the 1st is 6. R to the 3rd. Divide by 6. So I get r to the 3rd equals negative 27 over 64. Flip the exponent, or cube root it, excuse me. These cancel out, and you're left with r equals negative 3 over 4. So just a little reminder of how to solve equations with higher exponents. You simply can just flip the exponent. Okay, so here doing this, given the following terms of a geometric sequence, can you find a sub 3? So we're given a1 and a8. Can you find a3? Same idea. We always need this common ratio first. What is that common ratio? All right, so to find that, we use our formula. We're going to do a sub 8 equals a sub 1 times the common ratio, 8 minus 1. So A8 is 4374. It equals 2 times r to the 7th. Divide by 2. R to the 7th equals 2187. Raise both sides to the 1/7 power. And r equals 3. That's exciting. So now that I know that the common ratio is 3, I want to find a3. So now this is different. Okay, so now I'm going to use the formula a second time, but with a1 and a3. Okay, so I don't know what a3 is, so I'm going to plug that in there. But I know what a1 is, and I know the common ratio is 3. That's why I did all this work over here. And it's being raised to the 3 minus 1 power. I hate writing that, but just write that. And if you put it in your calculator, make sure it's all in the exponent there. So then a sub 3 is equal to 18. Done. Okay, that's exciting. See, that's a fun problem. You got to admit, right? Super awesome. Anyway, the given sequence has a common ratio of 3. If a1 is 5 and an is that, what's n? Okay, let's plug it in. That's all you have to do is plug it in. So a1 is 5. I'll plug it in. So it's the formula an, a1, r, which is 3, to the n minus 1 power. Now what's nice is they gave me this time. That's an a. They gave me that. They didn't give me the n. So I can plug in what I know. 3645 equals 5, which is this one, times 3 to the n minus 1. I'm just putting parentheses here so you know not to multiply these two together. So I just solve. Remember, whenever you're solving for an exponent, you use logarithms. So 3,645 divided by 5 is 729. It's 3 to the n minus 1 power. To solve for an exponent, you log or ln or log base 3, however you guys want to do it. And when you do this, this exponent can be brought out in front. So it becomes log of 729 equals n minus 1 times the log of 3. And when I do that, I simply divide by the log of 3. I'm going off my page, but you guys can go over here somewhere. So that is 6 equals n minus 1. Add 1. 7 is n. So that's the 7th term. This right here is the 7th term. Now you could have done this by just taking 3 and multiplying it by 5, and then by 3 again, then by 3 again, and getting to it. It's never a problem instead of using the formula. It's not a big deal. Okay, finally we just have a basic word problem, just so you can get an idea if you ever want to come back and study this. Okay, in a certain region, the number of highway accidents increases by 20% every 4 years. So that's a key right here. Every 4 years, it goes up 20%. So this is an example of exponential growth. Okay, every time you go up 20%, that is what you do. So in 2002, there were 5,120 accidents. If it went up 20%, I multiply it by 1 plus 20%. Okay, or in other words, that's 120%. Okay, this is, I wrote it like this so you would see that you remember doing the exponential growth and decay where you did 1 plus or minus the rate. Well, that's what's happening here. This is exponential growth, so we're adding. If it was exponential decay, you would subtract. So I just simply multiply 5120 times 1.2, and that's 6,144. Just to give you an idea of actually what's happening. This is, however, an exponential growth, and the explicit formula is a geometric sequence. So it's a sub n. We don't know what that is. We want explicit formula. Remember, leave n in the equation. The first term is 5,120. That was the first year they gave us in 2002. And we multiply that by the 1 plus the percent increase, or the minus the percent decrease, however you do it. And then to the n minus 1 power. So this is your explicit formula. Okay, this is the first term. This is A1. 1.2 is your common ratio. But to find it, you had to do 1 plus 0.2. So that's important that you realize that when you're doing these problems. And then they ask, use the explicit formula, the one we just found, to find the year that at least 10,600 accidents occurred. Okay, so to do that, our explicit formula, they're telling us a sub n. So they're telling us this number right here. So that's 10,600 equals 5,120 times 1.2. And we don't know what n is, so we have to solve for n. And you just solve. You may have to use logs. 5120, and that's 2.07. Okay, remember, if they don't tell you what it is, don't tell you to round. In fact, don't round in general. Okay, we log both sides. Take this n minus 1 out front. Okay, and then, so it's log of this mess. No, I don't want to write it. Log 2.0, that mess, equals n minus 1 times the log of 1.2. Okay, divide by the log of 1.2. And then you get approximately 4.99. I'm going to go over here. Sorry. 4.9912 equals n minus 1. I add 1, and I get approximately 4.99, which is 5.99, which is approximately 6. Okay, so n is 6. So remember, n here was every 4 years. So it's going to take 6 times 4, or 24 years. Did it say when? Find what year. So 2002 plus 24 is 2026. 2026, there'll be 10,000 accidents unless we get our hover cars, which I'm hoping for. Okay, sorry. So then there's this procedure just to, keep you aware. Solve the formula for R, always find the R. Sometimes you have to use 1 plus percent or 1 minus percent to do growth or decay. Determine the explicit formula, and then solve. You may have to use logs. Just remember, n is the term number, and a sub n is the value of the term. All right, have a good one.